Good morning. All right, so I don't know what we used on Tuesday when we were together last, but I'm just going to define a set A. So here's my set A, and I'm going to keep it nice and simple. Let's do A, B, C, D, E, F. Okay, so we've got those 6 elements to our set. So we're going to use that for a little while. So we talked about sets, we talked about terminology and lingo going on with sets. So we're going to continue on that. And today, as we go through, we're going to get up to the point where we're doing operations with sets. So there's something else about this set A that we can talk about, and we can go with the idea of what's called a subset. So a subset. So here's the definition of a subset. I can say this: set B is a subset of set A, and I'll show you the I'll show you the symbolism for this in a minute. If every element of B is an element of A. The symbolism for this, if I want to say if B is a subset of A, I would say this: B. Now this kind of looks like the less than or equal to symbol, if you're familiar with that in math, except it's curved. You use kind of like a U on the side. B is a subset. This is the subset symbol of A. So what we're going to do first is we're going to figure out a few examples, and you're going to help me to know if a set that I give you is a subset of set A right there. And it's just going to be a nice yes or no question, and want to get our feet wet and see if we can recognize if something's a subset or not. So here we go. There's my set A. So let's say, here's the question we're gonna answer: is B a subset of A? So I'm just going to write different versions of B here, and we're going to answer yes or no to each of these. So the first one, B. Let's say if B is equal to D and E. Is this set here a subset of that? Paula is shaking her head yes. Why? Well said. Because both of these elements here are found in A. That's what makes it a subset. So a subset just means you've scooped out some grouping of letters here and made a new or smaller set. So the answer to this one is yes. All right, I'm going to define a different B. And you're going to, same question. B is A, C, F. So don't answer out loud. Write that down real quick. Hypothesize your answer on your paper. Is that B a subset of A? And how would you answer that question? Yes, again. ACF. ACF. Great. Everything in B is also in A, so the answer to that is yes. Fantastic. Here's another B. And if you have a question, let me know. Remember, I love questions. I don't want you to sit there confused when your question is probably fairly easily answered. So here's another B. Let's say we have A, E, I, O, U. Is that a subset? So again, don't shout it out. Write down the set and then write yes or no. Is it a subset? Is this one a subset? Yes or no? Why not? Right. Even though A and E are in set A, doesn't matter. I, O, U, there's no I, O, and U over here. So this is a no. Do you kind of get the feeling for what a subset is? Are we doing all right? Okay, just here's a couple of special situations of subset that I want to mention. So here's the next one. Let's say B is A, B, C, D, E, F. Okay, so write that set down and take a moment. Is that a subset? All right, so what do you think? Is this a subset? Does it meet the definition? Is everything in here also in there? Yes. In fact, if you think about this, if you think about arithmetic, remember, I'm going to write the word yes in a second, but remember the symbol less than or equal to, right? So 4 less than or equal to 5, is that a true statement? It meets the less than part of it. Is 5 less than or equal to 5? Yes, it meets the equal part of it. So this is the same sort of thing with our subset symbol. And I'm going to talk to you about what this means if we just have the curved part alone. But right now, what we have is the situation where B equals A. And that matches the definition because everything in B, every element of B is an element of A. So this is a yes. This one that I'm going to write down is probably the hardest one. Let's say B is the empty set. The empty set is just a set with nothing in it. So we use some squigglies with nothing in it. If you need to make a note for yourself so you don't forget, that's the empty set. If you want, there's another symbol for the empty set. It's called the null symbol. It's just basically, it looks like an olive with a toothpick through it. Pick one or the other, pick your favorite and use that only. Don't combine them. More is not better. Okay, in fact, more would make a set with something in it. It won't be empty anymore. Okay, so I want you to hypothesize. This is the hardest question I've asked so far this morning. Is this a subset of that? So take a moment, think about that question, and I'll answer it for you in a minute. What do you think? Yes or no? Is this a subset? Is the empty set a subset of that over there? Okay, nice hypothesis. I appreciate the boldness. This is a difficult question. It's kind of a logic conundrum. Okay, I'm going to disagree with you. Okay, that's okay. Sorry, I know you're so bold too, and I love the enthusiasm. So please keep being like that. But I intentionally ask it because I want us to learn. This is a difficult question. The definition of subset says every element of the first set is also an element. Is there anything in there? Okay, so because of that, since there's nothing in here, then it stands to reason that everything that's in there, which is nothing, is also in there. Okay, so that might be difficult to understand. So you might just need to remember that the empty set is always a subset of any set. Okay, so yes. All right, we're almost done with this section. This is not a very long section for us to deal with. I've got this and then one other topic, and then we'll have kind of gone through what we needed to. Proper subset. All a proper subset is this. Proper subset is a subset. Let's say this. B is a proper subset if it is not equal to A. So a subset is proper if it is a subset that's not equal to the original set. The symbol for a proper subset is just as I alluded to a minute ago. What we do on the subset symbol is we leave the equal part off. Just like with our less than or equal to example, we can have just a less than. So here's what I would like you to do. From the 5 examples we just did, okay, I want you to circle the subsets that are also proper subsets. Okay, we did these 5 examples. Hopefully they're in your notes. I want you to circle the ones that are proper subsets. Well said. All right, so is this, I'm just changing the question, is this a proper subset? And I'm going to circle in red any of the ones that are proper subsets. So this first one, we said originally this was a subset. That's good. That's the first thing. Is it proper? Is it equal to the original set? Nope. So that would be proper. It is a smaller category. We've taken some little population, but not everything. How about this next one, ACF? We already identified it as a subset. That's the first thing that has to be true. Is it a proper subset? Is it equal to the original set? No. So it is proper. You tracking along with me? This one wasn't even a subset, so the question doesn't make sense. If it's not a subset, it can't be proper. Okay, how about this one? We said it was a subset. Is it proper? Right, because this one is the same. It's the equal set. Okay, so this one is not proper. In fact, spoilers. Whoops. Yeah, you can see that in the video, sort of. This is the only one that's not proper. The only subset that's not a proper subset is the equal set. Every other subset is proper. Even the No, that one, this one wasn't even a subset, so the question doesn't make any sense. Because first and foremost, to be a proper subset, you have to be a subset. Great. Great question. Good to clarify these things. Awesome. How about this one? Well, I just spoiled it. Since it was a subset and since it's not equal to the original set, it is proper as well. Okay, there's only one, when you get a little more specific, there's only one subset that's not proper, and that's the equal set. Okay, so there we go. All right, here's another set, just to change things up slightly. The odd numbers 1 through 15. So here's what I would like you to do. I'm going to write down a couple sets, and you're just going to answer, is it a subset, is it a proper subset? That's fine. I want you on your paper just to think about this question differently, to see how well we're learning. Just write down 2 subsets. Okay, on your paper, write down 2 subsets. I don't care what they are. And then you're going to tell me what you wrote down, or some of you are going to tell me what you wrote down, and we're going to see how they are. And then meanwhile, I'm going to write a couple sets up here, and I want you to tell me, is it a subset, and then is it a proper subset? Okay, when you're done writing down your two subsets you're making up on your own, here are these. I want you to identify them. Which ones are subsets? Which ones are proper subsets? Okay, that's the question. If they're both, I'm going to just write the symbols next to it. So just write each symbol, one or both or neither of them, depending on what the answer to the question is. All right, so somebody give me a couple of your sets. We're just confirming that you've written down subsets. So somebody tell me what one of your subsets is. Beautiful, great subset. Is this a proper subset also? It's wait. Oh yeah, it is. Remember, proper just means it's not equal. Okay, so that's the only thing it means. So yes, you caught it. 1, 9, 15, it's a subset, and then it's also proper. Great. What's another one? Somebody else give me, go ahead. 3, 6, 9, 12. I'm gonna disagree just a little bit. Is 6 an element over there? So let's change this and we'll make it a subset. What can we change this to make this? Sure, 7. Yeah, now it's a subset. Okay, so remember, this is great. See, this allows us to clarify. Any subset has to contain these things only. That's it. That's what I get to choose from. Okay, again, this is proper. Somebody else give me one. Sure. Perfect. That's a subset. Wonderful. One more. Oh, yes. No, let's change this to. Thank you. Got it. Great. Yes. These things have to be in there. And now they all are, so we're good to go. All right. One more.
1, 2, 7, 9, 8.
Okay, perfect. Don't be sorry. So if you're looking at your paper and you're like, are these subsets? If you want me to check them, I will later. Look at your sets, and as long as they contain these things here, you got it. If there's anything in your set that's not one of these, it's not a subset. Okay, so there we go. All right, so the answers to the questions here. Is this a subset? 3, 11, 13, 17. Why not? Because of the 17. So this is none of them. Great. Is this a subset? Yes, I'm going to write the subset symbol right there. Is it also a proper subset? Yeah, it's not equal. Perfect. Is this a subset? Is 11 part of that set up there? Yeah. And I'm going to spoil it. It's also a proper subset. So I'm just writing the symbols here that go along with it. Our good friend, the empty set. Is it a subset? Is it a proper subset? Indeed. 18 and 20. Is it a subset? Neither 18 nor 20 are part of my set, so that is a no. And then last but not least, 1, 3, 5, 7, 9, 11, 13, 15. Is that a subset? Yes. Is it a proper subset? Why not? Because it's equal. Perfect. Great job. Okay, one more thing from this section, unless you got a question. You got anything for me? Please bring it up. Let me know. But what we're going to do is we're going to answer the following question. I know it's on your mind. I can feel it. How many subsets does a set have? Okay, I know you were thinking it, and we're going to answer that question. Okay, so here we go. What we're going to do is we're going to use a little thing called inductive reasoning. We are going to make some examples, and then we are going to make a hypothesis from that about how many subsets we think something has. And so what I'm just going to do is we're just going to start with some small sets, and we are going to see if we can figure out what the pattern is. So here we go. A one element set. I'm just going to make it up. The set with A in it. So this is a one element set, the set with A in it. Let's list all the subsets because it's the fun thing to do this morning. So tell me a subset of this set right here. Empty set, fantastic, I love it. What else? A, there you go. Those are the only two subsets because that's not a very interesting set at all. I'm just going to draw a little line here to separate from the next one. So a one element set has 2 subsets. Next thing we're going to do this for a couple sets, but this gets bulky really quick, so we're not going to do this for too long. A 2 element set. I'm going to be super clever here. Instead of the set with A in it, it's going to be the set with A and B in it. All right, tell me a subset of this set right here. Empty set, yes. Good to get that one out first. I love it. What else is a subset of this set right here? A. What else? And then there's one more. AB. How many subsets is that of the set with 2 elements? 1, 2, 3, 4. We're going to do this one more time, just because there's one more that won't be too terribly bulky for us to do. And then I'm going to ask you if you can spot the pattern that's going on right there. Okay, so 3 elements. So again, I'm super clever. A, B, C. What are the subsets? Give me some. Let's do the 1 element subsets. We've got A, then we've got B, then we've got C. How about 2 element subsets? What are those going to be? AB, certainly. AC, great. And one more, BC. So we got the empty set, we've got all the 1 element subsets, we've got the 2 element subsets. There's one more. Okay, I'm going to give you a second to write that down. I know your wrist's probably hurting. I don't need to, it's only the second day of class, so I don't need to make you write so fast. But when you're done writing down those subsets, here's the question. We got a 3 element set. How many subsets do you count up there? Okay. Yes, there are 8 subsets. So here's the question. When I had 1 element, I had 2 subsets. 2 elements gave me 4 subsets. 3 elements gave me 8 subsets. What's going on every time I add another element to my set and I count up the number of subsets? What, I'm sorry, what'd you say? Somebody said it. Perfect. I just can't hear with the mask, and then I got this air conditioner here, and I don't hear great anyway, so I've got a lot of challenges, so I apologize. All right, so if we're not going to list this out, but if we're going to follow the pattern, what you said, which is 100% right, what if we had a 4 element set? How many subsets would you expect? And you nailed it. 16. We would go from 8 to 16. If we added a 5th element, it would jump up to 32. A sixth element would mean that we'd be listing all day. We have 64 subsets, and that would be a terrible project to take on. So here is the general pattern. How many subsets does a set have? The answer is this. It is 2 to the n power. Where, and I'm going to write in parentheses, n is the number of elements, meaning the cardinality, which is what you just showed me by deductive reasoning. Okay, so let me do one of these problems. This will be the last thing that we talk about in this section. We're done just about, but I just want to show you a brief application of when you get on your homework, where you're going to see this, so that you can recognize it. This is just a problem that I have staring me in the face in the book. I'm not going to write out the whole problem, but it says this. Okay, some people are going to install a pool. So I'm going to read the problem. I'll summarize it up here. It says the Fitzgeralds are installing an in-ground pool in their backyard. They can either install the base model offered by the pool company or add any of the following options. So here are the options. They can have an automatic pool cleaner. They can have a solar cover. That sounds fancy. They can have a waterfall. That sounds very relaxing. They can have a hot tub. Oh, that sounds perfect. A fountain. These are a lot of options. Leave myself a lot of room. A slide or a diving board. And the question is, how many variations could they choose? I'm going to give you a second to write that down. I know there's a lot of words going on there. Meaning, how many different types of pools can they choose from if they chose different combinations or different subsets of the pool options? So again, just translating what we're doing into, us thinking about it. If this family did not want any of the options, they're just going with the basic pool, that's the empty set. If the family just wanted a pool cleaner and a solar cover, that's a subset with 2 items in it. If they wanted everything because they were all in on their pool, that is the equal set. Okay, so that's how this is applying. This is the set of options that they can choose for their pool. And so what I want to know is how many different subsets, how many different varieties of pools are there? Well, we just talked about this. The answer to the question goes like this. Basically the question is, how many subsets of these options are there? Well, it's 2 to the what power? 1, 2, 3, 4, 5, 6, 7. That's exactly right.
Don't you have to add just the pool?
Just the pool would be the empty set.
Right.
Because if you don't have any of these, then you have just the pool. So that doesn't make any, they're getting the pool. This is the set of options. Okay, so if they don't choose any of these options, that's the empty set. The empty set's a subset of this. We talked about that the empty set's the subset of everything. So you don't have to add in the pool, because the reason why, it wouldn't make sense, if I'm talking about subsets, it wouldn't make sense for them to choose the solar cover and the waterfall, but not the pool. They have to buy the pool. That goes with it. Okay. So that's a really great question. I'm glad you asked it, because that would be my question if I was doing the homework. And then 2 to the 7th. If you don't know how to do exponents on your calculator, see me after class. It'll take us 2 seconds, but let's see. 2 to the 2. That would be it. So there's 128 different options. So that pool company would say, oh, we got 128 different options. And there you go.